wanted to find the square root of 1, I need to think about what times what gives me 1. 1. And then the square root of 4 is 2. Whoops. Because it's like 2 times 2.
It's like the reverse of that.
It's like the reverse. Yes, it's like the inverse. The square root of 9 is 3 because 3 times 3 is 9.
Are you going to give us like decimals?
No, we are not going to get decimals. We're going to simplify rather than giving decimals.
And your radicals.
Wait, can you use the easy way of simplifying radicals or something else? Oh, okay.
I'm going to try. Okay? So these are inverses of one another. Squaring a number and taking the square root are inverse operations. They undo each other. Okay? So these are what we would call the perfect squares, and then on the right-hand side, the perfect square roots. We can continue that pattern. But the question becomes, what if the number isn't nice and perfect? How is that going to look? And we're not going to use decimals. We're going to simplify it so we've got a square root. So your calculator is probably not going to help you a whole lot. Okay? No decimal answers. Okay? So let's look at one. Anybody have any questions before I move on with the perfects? We're going to do some, just a minute. Okay? All right, let's do an example. We're going to do the square root of 12. Is 12 a nice perfect square?
No.
Absolutely not, right? So here's what we're going to do. Step 1 is I make a factor tree, like you did back in elementary school. Give me 2 numbers that multiply to 12. 2 and 6 or 3 and 4. Doesn't matter. Okay, I'm going to use 2 and 6. And then I'm going to keep going until I can't factor anymore. So 6 is 2 times 3. Okay? Until I get all the prime factorization. This is 2. So do you agree that if I do 2 times 2 times 3, I'd get 12? Yeah? So now look, I'm going to rewrite this. Wait a minute. Give me a chance. Give me a chance. I'm going to rewrite this as 2 squared, because see how there's 2 of them? Times 3. Now we just said that this little square and this square root undo one another, right? So I'm going to have 2 square root 3. Okay? Is it? Okay.
I mean, but he takes out a step.
Now, let me, shh. How many of you have played Monopoly before? Okay. What happens if you get in jail? How do you get out of jail in Monopoly? Well, you can pay. What do you do with the dice, though, to get out? Roll doubles. So, the name of the game here for square roots is to roll doubles. If you look at the prime factorization, roll doubles. One person comes out, the 3 doesn't have a partner, he has to stay in jail. All right, let's do another one. Let's do,
45.
What's 45? Okay, we'll do 45. So I'm going to come over here, I'm going to do a factor tree. 2 square root of 3. 2 times the square root of 3 is the same as the square root of 12. All right, square root of 45. Let's do a factor tree for it. Give me 2 numbers that multiply for 45.
15 and 3.
9 and 5. Or you can do 15 and 3. The beauty of the factor tree is it doesn't matter which pair of numbers you choose.
You just got to go back to your roots.
There you go. So we look at this last one. So I have a double 3. So I could rewrite this as 3 squared times the square root of 5. The little 2 and the square root are inverse operations. They cancel each other out. So we get 3 times the square root of 5.
Wait, what cancels each other out?
The little exponent of a 2 and the square root.
All right, Paul.
Yes, Brendan. Let's, guys, stop. Go ahead and ask.
What if it's like 3 cubes or something like that? Will it ever be like it or no?
3 cube.
Like cubes.
Well, we're looking for doubles. So let me do one. Let me think of one. That's a good question. Let me think of one. I gotta make it work out though. You want one that would be like a cube. So let's do. Let's do the square root of 24. I think would work. No, well, 12 times 2 is 24, but you got to think about what number times itself.
The square root of
Okay, so, okay.
4 is 12.
No, it's not 12. We're not dividing.
Square root of 144.
Oh, yes. All right, so factor tree 24. What would give us 24 if we multiply? 6 and 4, or you could do 3 and 8. It doesn't matter. And then we're going to keep factoring until we get to primes. This would be 2 times 3. This would be 2 times 2. So here, if we look at this last line, you see how there's 3 different 2's? I'm not going to write it as 2 cubed because the name of the game is square root. I'm looking for pairs. So I'm going to write it as 2 squared times the square root of 2 times the square root of 3. And the little 2 exponent and the square root cancel. What do you think we're left with? 6. 2 times 3. So we're just simplifying. Yes, we're simplifying.
Not that algebra with the A. I feel like you did 96.
Well, if there's the same question, make sure you get the same answer. All right, let's do a real hard one. Let's try one more. You try
96.
96. Is that one a hard one? All right, you try this one. Yeah, if I put this in my calculator, I can see the decimal. If I put 4 times the square root of 6, I should see the same decimal. This is equivalent to the square root of 96. They're equivalent. So your calculator, you should get the same decimal. If you don't, then you know you've made a mistake. Maybe you dropped a number or something to that effect. Okay? All right. I want to show you a little bit of the vocabulary about what we call these numbers. Okay? So some vocab. The part underneath the radical or underneath the check mark, this is called a radicand. This is called a radical, the check mark symbol. And then if there's a number here, we call this the index. Now, if there's not a number written here, we understand it to be a 2 for square root. But you could also do cube roots and the 4th roots and the 5th roots, however many. And all that does is changes the name of the game. Instead of rolling doubles, if the index is a 3, you'd have to roll triples. Okay, let's do one that's a little bit larger. And this time, let's do the cube root of 8. This one is perfect, as Renner let out of the bag. So if we were to do a factor tree for 8, 2 numbers that give you 8, 4 and 2, and then 4 breaks down into 2 and 2. This time the index is a 3, so the name of the game is to roll triples. So I would have 2 cubed. And now the index and the exponent cancel, and we just get a 2. So it does work for higher powers. Why are you hollering?
She took a picture of me. I want to see it.